Hi everyone, welcome. I'm Mark McLean, Sparky Mark, and welcome to this Wednesday session for MEL Academy. Yeah. Now I'm hearing a little bit of feedback through that. I think we have a little bit of a, yeah, there we go, perfect. All right, fantastic. Just making sure we get everything. I can see lots of people. The attendees number is going up and up and up, so lots of people are just arriving. So hello, as I said, welcome. I'm Mark McLean, Sparky Mark, and this is your Wednesday MEL Academy session. So now, just to remind you guys, those of you who've been here before, Kat is in the chat. Yes, that does rhyme, and she's here. If you've got any questions, she's under MEL Academy there. So any questions you guys have, any issues with sound or visual or anything, please let her know. We are super lucky to have her, super fortunate to have her here. So say hi to Kat, please. That's K-A-T. Now, if you haven't done it already, you guys are already straight into it. Can you please put down where you guys are tuning in from? So where are you located right now? I can see there's Alberta, Canada, Ohio, Indiana. So fantastic. Whereabouts in the USA? I can see people say USA and Canada. Jacksonville, Florida, that's fantastic. Toronto, that's New Jersey. Lovely. I love hearing where you guys are from. I'm located here in London right now, and I can see, so you guys are all over the world, which is really fantastic. I can also see, hello, yes, and also welcome to those of you guys that are joining us on YouTube, on Facebook, on Instagram. And yes, as I say, welcome to the MEL Academy Wednesday session. Fantastic. All right, great. Now today, this is a special session. It's we've sort of been we've been running these obviously webinars and things, but we are now all the people who are subscribers to the MEL Academy science sets. So if you receive them and things like that, then we wanted to do something a bit special for you guys. We're actually going to do one of the MEL science experiments today. Normally what we try and do on the other days is lots of DIY experiments and things like that, but we're just doing one for the MEL science subscribers. And look, if you don't have the set though, you are more than welcome as well. Even if you're not sure, what I'm going to do is I'm going to make sure you can see everything that's going on. And so even if you don't have the set, it's wonderful. You get to join in, which is great. And so I love watching these, even if I don't have the sets, because it's quite fun. Now, as I said, the reason for doing a single session on one experiment, as I say, on the other days, if you want to join in and do some home experiments, it's super fun. I really recommend doing it. But one of the reasons we're doing just one experiment on a Wednesday is that we want to go a little bit deeper into the science and really understand what's going on. So this is a little bit of a deeper session, basically. Now, so with that in mind, if those of you guys who have the MEL Science Kit, it's the tin set, okay? And we're going to be doing tin dendrite, okay? We're going to be growing these amazing looking metal sort of tin trees, which is pretty cool. But we'll have more on that in a bit. Now, obviously, you're going to need 4 AAA batteries as well to go with that. And the other thing I'm also going to sort of ask you guys to do. Now, this is whether or not you're a subscriber or not, basically. What I'd love for you guys to do is to go onto the app stores, so the iOS or Android stores for your tablet or whatever, and I'd love you to download the MEL Science, basically the MEL Science apps. Okay, so there's one called MEL VR. That's MEL space VR, and there's another one called MEL Chemistry, and another one called MEL Kids. Okay, fantastic. Now, if you can't for some reason download it, remember they're free. They're completely free. There's no hidden things, costs inside of it. It's just completely free. The reason I want to do that is I'm going to show you some stuff in the apps which are really, really fantastic. So I just wanted to put that right up at the front. Please download those apps, and I can see some of the people on Facebook there. Welcome, guys. Welcome to Facebook, and you have the tin set as well, which is fantastic. So join in, which is fantastic. I see someone from Tokyo, Japan. It must be either pretty early or pretty late there. So here we go. Right, now, just for those people who are not joining us on the Zoom here, there is just below me here we've got the melscience.com/academy, and you can sign up, and therefore you can be part of all the polls and things like that. It's free. Just join up, and it's I think it's really fun, and you've also got Kat in the chat there who can answer questions. Now, I want to introduce you to someone. This is Owlie. Owlie is was my toy stuffed owl toy from when I was a baby, actually, and came all the way with me from South Africa when I was a kid to London. And oh, sorry, Owlie, what's up? Oh, every time. Owlie doesn't. He thinks he's a real owl. He doesn't like being called a toy, so he thinks he's a real owl. Yes, sorry, Owlie. Yes, you are a real owl. Yes, definitely. Whoa, no, I'm not being sarcastic. No, I know my voice sounds like I'm being sarcastic, that I'm saying, oh, you're a real owl, but no, you're definitely a real owl living in a house with a human being doing science experiments. Yeah, I think, yes, no, sorry, you're definitely real. Now, anyway, as I said, Owlie has been with me. He's helped me with a few experiments before, and actually, you guys seem to really like him. So people kept asking for him to come back. So now he's back, and he's here. I think it almost seems like you guys like him more than you like me. But actually, to be fair, look at this face. Just such a lovely face. Anyway, super lucky to live with Owlie. He makes sure that I'm safe, that I wear my gloves, my gauze, keeps me very safe and things like that. And also means I've got some company as well, which is really nice. So anyway, Owlie, yes. Oh, yes, sorry. Owlie just reminded me, we were on his owl pad the other day. It's like an iPad, but it's an owl. It's not a funny joke. But we were looking through all the social media posts. So you guys posting on Facebook, on Instagram, on Twitter, on TikTok, and lots of other stuff, and you guys sharing your pictures. Now the thing is, the problem is we are located here in London. Okay, this is where we are, and you can see us, you can hear us, but we can't see you guys. Now, of course, you guys have you can put in the chat, which is fantastic, and I can see your names, and thank you, Cincinnati, and fantastic that you guys have joined us. Thank you, but we can't see you. So if you're doing these experiments, and again, especially with the DIY ones that'll be very colorful and really fun and things like that, if you're doing them, please take photographs, make videos, things like that, and post them on social media. If you're not on social media yourself, then get your parents and hashtag MEL Science. It's just here in front of Owlie here, right here. Okay, hashtag MEL Science, okay? And then that way, that's what we do. Owlie and I will often sit there. We actually did this last night. We sat there and we went through all the social media, looking at all the hashtag and just seeing the wonderful things you guys are doing, because we're broadcasting to loads of you. There's loads of you guys out there. No, they're there. Look, yeah, look. If you look at that camera up there, Owlie, they're just in there. No, they're not actually in the camera. They're in their own homes, but yeah, I'll tell you what, I'll explain it later. Owlie. Anyway, yes, so I have to explain it to the owl later. But essentially, I know you guys are here, we know you're there, but we'd love to see what you're doing. So please, if you could either do that, post it on social media and put the hashtag, or if you don't have it, email melacademy@melscience.com, please. And I tell you what, send the pictures, send the videos. We love seeing them. It's so nice. I got forwarded a few the other day where some of you guys had your own toy owls and they joined you in an experiment. So please, I love that stuff. It's really fun. We love that stuff. So if you could send it, yeah, send it to us and we'll feature the best ones. So this way, I think it's much better that we get to see what you're doing, which makes us really happy, doesn't it, Owlie? Yeah, fantastic. Now, Owlie, will you come back a little bit later and help me with an experiment? He loves experiments. Fantastic. All right, thanks, Owlie. Okay, brilliant. Now, today's session is on tin dendrite, okay? But really, it is a session about the wonders of electrolysis, okay, and electricity in chemistry. And I'm going to explain what electrolysis is. But the first thing I'm going to ask you guys to do is just let me know, have you heard of electricity before? Now, I'm pretty sure you have, but this is just a good way for me to get there. Can you put your hands up? So on Zoom, there's a little button that says raise hand. Also, this is just seeing that you guys are alive and that you're there and you can hear me okay. I can see, wow, lots of raised hands. And if you guys are on Facebook, you can pop into, or on YouTube or any of the other ones. There's, I think there's Twitch as well and Instagram as well. The only problem with Instagram, sadly, is that's the only one that I can't see the comments on, sadly. I'm really sorry about that. But what I will do is we'll read through them later, basically. But as I said, please, if you if you do want to be involved in the conversation and have all your kind of comments and things like that, I can see all the Facebook and stuff, but just, here we go, melscience.com/academy, and then that way you guys are signed in and you can be part of all that. Right, okay, cool. I see loads of people. Wow, loads of hands up. Thank you very much on Zoom. That's amazing. Almost everyone has heard of electricity. You guys are pretty good at putting your hands up. You can put them down now. Thank you so much. Right, I assumed you had heard of electricity, okay? So I'm not trying to condescend you guys, but electricity is vitally important for, especially within today's society. It doesn't just do the lights around us that means we can see it in the night. It also can be used for an amazing amount of other things. So, for example, running the internet, our computers, our phones, all of that stuff uses electricity, which is pretty cool. And in fact, the reason you can see me is because electricity exists, which is fantastic. All right, brilliant. Now, one of the other things we can do with electricity, which is actually pretty amazing, is we can actually split chemicals apart. Substances can actually be split apart using electricity. And in fact, one of the first things that electricity was actually used for was splitting water up into the things that make it up. Now, what are the things that make it up? So those of you guys who've seen my webinars before know that I love atoms. I love atoms. They're just really, really cool. Okay. Now there is a joke. Why can you never trust an atom? Because they make everything up. Well, they make up everything. I think I failed on that joke already, so that's it. Now let me there is some truth there. So essentially, they do make up everything. Everything around us is made of atoms. So I'm made of atoms. You're made of atoms. This table's made of atoms. In fact, Owlie here, okay, my little owl friend, he's made of atoms as well. Sorry, Owlie, what are you saying? Yeah, Owlie says that because I'm bigger than him, he thinks that I'm made of more atoms than he is, which actually sort of makes some sense, I suppose. Wait, are you saying that I'm... Owlie. Anyway, yes, so essentially now it isn't as simple as bigger things have more atoms, because sometimes they're more spread out, these atoms and things like that. But in general, that's absolutely right. The more atoms something has, the bigger it is, and also the sort of the heavier. But we'll talk about that in a minute. So what are these atoms? Now, atoms are the building blocks, okay, of the universe. They're the building blocks of everything around us, including me, you, as I say, the world, and Owlie and things like that. Okay, now they are tiny, tiny little things. Now what I'm going to do is I'm going to represent them using this little ball here, but they're not as big as this. They are so, so tiny. They're the building blocks that join together to make the world around us, okay? Now, I sort of see them being a bit like Lego bricks. You could put Lego bricks together and make a house. Fine. You could then take that Lego house apart and make a big dinosaur, or you could make a car, okay? So as I said, for lots of you who've been to my sessions, my webinars before, you'll sort of have heard this before, but I just need to make sure that everyone is on the same sort of page, okay? So atoms, really, really tiny. In fact, if I take a pin here, like I've just got this little board pin, little push pin here, okay? On the tip of it, which is actually very careful because it's very, very sharp, it's actually really, really small, this tip of this pin. Even just on the tip of that, there are millions and millions and millions of atoms, okay? In fact, they're so small we can't even see them under a microscope. But when they group together in large amounts, and I'm talking not 10 of them or 20, I'm talking millions and millions and millions of them, we can actually see them. So for example, if you hold your hand out in front of your face, okay, so if you just hold your hand out in front of your face, there we go, look at your hand. Now, your hand is made of atoms. Well, why can we see your hand? Because there's so many of these atoms there. Okay, now that's something I've talked about before, but today we're going to go a little bit deeper. We're going to talk about what atoms are actually made of. Okay, now there is a wonderful app made by MEL Chemistry, well, the MEL Science team, and I love these. I kind of spend a lot of time kind of just browsing. Owlie and I have spent quite a lot of time actually browsing those, just kind of having a look at all the different things you can do on them. And what I'm going to do is I'm going to show you what an atom is made of using a demonstration, because remember, they're too small for us to see. Okay, so we're going to use this, we're going to use the app to see. But the first thing I just want to quickly tell you is that atoms, okay, are made of things called protons, neutrons, and electrons. Okay. Now, of course, protons and neutrons and things are made of smaller things, and we don't need to worry too much about the science of those. But this is the main thing I want you to understand, is they're made of protons, neutrons, and electrons. Now, protons are positive. Neutrons are neutral. They don't really do too much, and we're not going to really worry about them right now. They just kind of take up space. But the thing we're actually going to spend quite a lot of time on is something called an electron, or at least that we're going to be discussing later on as we go, because electrons are really important for chemistry and really important for electricity, because electricity is moving electrons. Okay, electricity, moving electrons, fantastic. We'll go over that in a second. But as I said, now they're made of these. So we've got protons in the center and neutrons as well in the center. Okay, so atoms, instead of being little balls like this, actually are a very central nucleus, little center part, with protons and neutrons in them, which means it's positive in the center, and around the outside are negative electrons. Now, what I'm going to get you to do is, I think it's easier if you see this, okay? So on my iPad here, I've got the MEL Chemistry app here, okay? But there's also the MEL VR, okay? Now that MEL Virtual Reality. Now, what's really cool about the Virtual Reality app is you can actually put it onto your phone, okay, and then what you can actually do is we've got this. It comes with the MEL Science Kit. So as I say, it's a special session today for people who got it. You can actually make these little cardboard glasses. They come with the set. But to be honest, even if you haven't got the set, you can actually make your own ones of these. And I really do encourage you to make your own ones if you haven't got it. Otherwise, there's tons of designs online to do it. So if you put VR, cardboard VR, iPhone or something like that, it'll show you how to make them. But essentially what you can do with this here, which is really clever, is you pop your smartphone into this, okay, and just put this there, and then you can actually look into these holes, and it will actually allow you to look around, and it looks as if you're actually in the environment. It's really, really cool. Again, as I said, it comes with the MEL Science Kit, but you can make your own, and I'm fully... Now, I'm not going to use that one because obviously it'd be very hard to show you that. And I'm going to show you how, and the MEL design team, I have to say, the tech people who built this stuff, really, really great. What's happened is they found a way that you can do it without having to do it on there. So what you do is you go into the MEL Chemistry app, okay? And then what we've got here is a list, tons and tons of wonderful experiments that you can do, okay? That you can see as well, and guides to those, which is great. And there's some great videos and things like that. Now, they're constantly updating it, which is great. But the bit we're interested in is right at the bottom. It says VR Lessons, just on the bottom here. It says VR Lessons. And we click that, there's a button that says Open 3D Lessons. Okay, so that's what we're going to do. We're going to click Open 3D Lessons, and we end up in this place here. Now, this is the MEL VR lab. It's like a sort of lab, and you can go through and you can learn about lots of different stuff. So don't worry, I'm going to share my screen with you in a second so you actually be able to see this a little bit better. But you can sort of go side to side and look at these different things, stuff about gases. Now, the one we're going to do is the page on atoms. I sort of prefer doing this on my phone, actually, but the reason I'm doing it on the iPad is so I can show you a little bit better, okay? And we're going to go and we're going to build our own sodium atom. Now, let me just quickly tell you this before we do this, is there are about 100 or so different types of atoms. Okay, like Lego bricks. Imagine that there were only 100 types of Lego bricks. Not that there are 100 Lego bricks, I'm talking there are millions of them, but there are only about 100 or so. In fact, there are way more Lego bricks. But naturally occurring atoms, there's only about 100 or so. Now, one of them is called hydrogen, another one's called oxygen. They combine together to make water molecules. But this sodium is a type of atom, and we're going to have a look at it. We're going to build our own within the app. Okay, so if you click on the sodium atom one there, now what I'm going to do is I'm going to share my screen with you guys. I'm sorry for those of you who have a narrower screen because you're on your handheld device, but hopefully you'll get to see the middle bit basically. Okay, fantastic. All right, now if you haven't had a chance to download it, don't worry, it's okay. You're just going to go into the atoms section, and you can actually just have a browse around anyway, okay? But I just wanted to show you one of the things that can be done on there. I'm not going to go on too much about that, right? Okay, so let's have a look at this. So what I'm going to do is, here we go. Let me share my screen with you. Here we go. And then what I'll do is I'll click the sodium atom one. Okay, and click sodium atom.
Make a sodium atom 23 Na. A sodium atom contains 11 protons.
Okay, so what I'm going to do using the app is I'm going to actually be able to press protons there and increase the number of protons, okay? And then what I'm going to do is I need 12 neutrons. Now, you don't need to worry about the numbers here, but a sodium atom has 11 protons and 12 neutrons, so I'm just going to add those together and then click fuse. Okay, so here we go. Let's just do this. I add some protons together in the center. Okay, there we go. 11 of those, 12 neutrons. Remember, neutrons are neutral. There we go. And now I'm going to click there we go, got 12 of those. I click fuse now, so they're fused together as a central nucleus. Now I'm going to start adding 11 electrons. Can you see there's electrons around the outside? There we go, and they make these amazing shapes as well, which is really, really cool, and 11 of those electrons. Okay, and I click that, and now I've got sodium, and there's a little picture of the sodium there next to me. Okay, all right, so as I said, it's pretty cool, this app. It allows you to kind of build your own atoms and have a look, but just the core of this, look, as I said, just to make sure that you guys are on the same page, atoms are made of these little protons and neutrons in the center, and they've got these sort of clouds of electrons that kind of float around the outside. Now, because the electrons are on the outside, it's possible to remove electrons from it or add extra electrons, okay? And atoms, it is possible, as I said, to remove electrons or add them. Okay, a good example of that is, say for example, I take a balloon and I blow a balloon up, okay? I blow a balloon up, so I blow it up, and tie it up. Then what I can do is rub the balloon on my head, okay? If I rub this balloon on my head, what I'm actually doing is removing these outside electrons. Now, I don't know if you guys have ever heard the expression opposites attract. Have you ever heard that? Opposites attract. I can see lots of yeses. How about you guys on Facebook and YouTube and other places as well? Have you ever heard the expression opposites attract? Now, someone's written there in the comments, magnets. Absolutely right. Now, with magnets, you have a north pole and a south pole, and they will actually attract each other. They'll actually be stuck together. If they're the same, they repel. They kind of move away, and I can see, good, great, you guys on Facebook as well. I've got this too. So that's fantastic. So, as I said, opposites attract. Now, protons are positive, electrons are negative, and they're actually attracted to each other. In general, most atoms have the same number of protons as electrons, which is fantastic. And that's what happens in the balloon. But when I blow it up and I rub it on my head, I'm actually removing electrons. Okay, we call these ions. When an atom has lost or gained electrons, it's called an ion. You don't need to worry too much about the name. But essentially what I'm saying here is that the balloon, I've removed the electrons. And in fact, what will happen, if you try the experiment yourself, it will actually stick to the wall. It's a really, really cool experiment. I rather enjoy it. So blow up a balloon, rub it on your head, and it will stick to the wall. The reason is I've removed the electrons from the balloon. Now, because electrons are negatively charged, as I say, I just need to get through this theory, and I just want you to make sure you understand this bit so we can actually get onto the experiment and understand what's going on. But if I've rubbed the balloon, removed its negativity, the balloon now becomes positively charged. It's now positive. And the reason it sticks to the wall, which is actually a really cool experiment, is the wall has lots of electrons inside it, and so it's attracted to those, which is really, really cool. So as I said, atoms, you can remove electrons or add extra ones, and that is the basis of what we are doing now today, okay? And we're going to be doing, now electricity is the movement of electrons, so we're going to get some electricity, okay? So from the set, you can get this little battery holder, and we're going to put 4 AAA batteries into this, okay? All right. It is possible also to use sort of a square battery or something like that, but this is the sort of the best. And you could just use one battery, but the reason for using 4 is just to speed the process up, and it makes it a little bit more powerful, so it looks really cool, okay? So we're going to get that. Now, electricity is the movement of electrons, okay? Now, the last thing, well, there we go, I need you guys to understand before we can do the experiment, is these are the chemicals we're going to be using. And let me cut to the table here. So this first one here is, here we go now, sorry, I suddenly realized I need to make sure I focus this. This is sodium hydrogen sulfate, okay? That's the sodium hydrogen sulfate. And let me quickly go to the next one. And the next one is called tin chloride, tin 2 chloride, okay? All right, now, okay, what are these things that I'm showing you? Now, I just want you to understand, when I did chemistry at school, what would happen is the teachers would be like, we've got these 2 chemicals, we're going to mix them together and something's going to happen. I didn't really know why we picked these chemicals, okay? And no one ever really told me this. But what's actually happening is some chemicals will react together to do cool things, okay? And sometimes they just don't. The problem is that it's... to remember every single one of them is quite hard. So what chemists do is they find rules and they find general principles that happen so you can predict what might happen. That's when chemistry starts getting really interesting. And in fact, the modern day inventors, you know, one of the things I wanted to do when I was a kid, I wanted to become an inventor and invent cool robots and other cool things. Modern inventors are building new chemicals and new amazing things, like, for example, the plastics or new carbon nanotubes, or amazing things that will help us be able to get into space and that kind of stuff and be able to live longer and make life a lot better. In fact, some people are inventing sheets that might absorb carbon monoxide from the air and therefore make, you know, the greenhouse gases not so bad. But as I say, don't panic too much about like all the different things you can do about it with these chemicals. But as I say, we have picked, or MEL Science has picked, these two chemicals because they do something really, really cool. And I'm going to try and explain what they do and why they do it. Okay. Now, what I need you to understand is this. Remember that we had atoms, okay? So I've got my little atoms here. Now, this is my interpretation of a water molecule, okay? And this is a hydrogen atom here, and this is a hydrogen atom. Now, of course, the real thing is so much smaller, we can't see it. But I'm going to use this as a representation. So what we've got is a hydrogen atom here and a hydrogen atom. Hydrogen is a type of atom that when it groups together in pairs, it becomes hydrogen gas. It's highly explosive. It's one of my favorite elements, atoms. I love it. It's really, really fun because it explodes in a really cool way. Oxygen is a gas that we need to breathe. But when these combine together, two hydrogens and one oxygen, they form water. It's pretty amazing. So these two gases, when they come together, they behave very differently. They behave like water. Okay. I can see lots of people saying they're ready. They've got their stuff. That's fantastic. Well done, guys. So we're gonna get going. Great. Now, water molecules. Okay. Now, water's really, really interesting. Water. One of the reasons it's so important for life is when certain other chemicals, we call them ionic substances or salts, dissolve in water, what they do is they split apart. So this, I'm going to give you an example. Table salt, you know, the salt that you put on your French fries or chips, that salt, just, you know, we're told not to have too much of it, but it's kind of tasty. That salt is actually made of a sodium atom, which was that one we just built, and a chlorine atom. Okay. Now what actually happens is certain atoms have a tendency to just lose electrons. You just lose them. And you're like, oh, sodium, you've just lost an electron. And sodium's like, oh, no, I just lost my electron. It does just happen. Okay, now, so as I said, when you go deeper into chemistry, you start to understand why, and certainly also physics, why they lose those electrons. But all I need you to understand is certain atoms lose electrons on their own and certain ones gain them. Okay, now chlorine is one of those ones that does happen to gain an electron. And sodium is one of those ones that happens to just lose an electron. Now, do you remember I said opposites attract? Well, when the sodium's lost an electron, it becomes positive. And when the chlorine has gained an electron, it becomes negative because it's got too much negativity. So what actually happens is they're attracted to each other. So within salt that you put on your chips and things like that, what actually happens is this is very much, they're arranged and they're stuck together like this in this sort of lattice formation in rows and columns, which is really nice. But when you dissolve it in water, and this is one of the incredible things about water, is water allows them to break apart. So they can just float around. Okay? And they just float around. Now that's also why, as I said, water is so important for life, because if they can't just float around, they'll just be stuck the way they are. And inside the body, there's constantly changes happening where we need these chemicals to recombine in different ways. Right, so now, here we go. Now I see someone's written metals lose, non-metals gain. That's absolutely right. So in general, metal things lose electrons, okay? And we're going to use that today. So let me give you an example of this. What I've got here is I've got my tin chloride. Now tin is a type of metal, okay, like iron or lead or, you know, aluminium or aluminum as you guys call it, and tin is just a type of lead. In fact, tin cans, I don't know if you ever heard of tin cans, usually because they used to be made of tin, now they're made of other things too, but essentially tin can be just dug out of the ground. The only problem with this tin very often is it's bonded to something else. It's been already reacted with something else. So how do we separate it? How do we get it on its own? So this is the core of everything we're doing today, and I promise we're going to get on and we're actually going to see some cool stuff right now, okay? I just want you to understand this. We use electricity. Because electricity is moving electrons, do you remember the electrons around the outside? Okay? Because it's moving electrons, we can actually give back the electrons that tin is missing. So tin has lost an electron. If we can give it back its electron, here, little tin, have back the electron you lost. I'm not sure why I'm saying it like that. But if you give back that electron to the tin now can be free. Instead of just floating around in the mixture, it actually becomes tin. And that's what we're going to see today. All right, fantastic. Great. So can I just, look, on Zoom, Kat, who's the moderator on there, could you please just quickly give me the poll for what are electrons, please? So I just want to remind everyone, we'll just do a couple of polls and then we're going to keep going. So what are electrons? Are they just chemical reagents? Are they negatively charged particles inside the atom? Are they positively charged particles inside the atom? Is it the surname of two famous scientists, or is it particles of light? Okay, now I'm sorry for everyone else who's not on Zoom. You can't actually see that, but I've read out all the options for you guys. As I said, if you want to join in and do the polls and be part of that conversation, it's just down here, melscience.com/academy. As I say, it's free, and it's really useful because then you can kind of, there we go, have a look. All right, yeah, and I can see 63% of people said negatively charged particles inside the atoms. Now, I can see 28% of people said positively charged. Don't worry, it is a bit confusing which one's which. Protons are positive, pro-positive, okay? And I can see, yes, people on Facebook, well done, Kerry, yes, absolutely negative particles. Well done, guys. So what's happening here is around the outside are these negatively charged electrons. So they should be called like electrons, like negative electron. I don't know, they're called electrons. So protons are positive, electrons are negative. Okay, fantastic. Right, now what's going to happen here? I've got my tin chloride, but it's trapped in this substance of tin chloride. In order to separate it, we are going to use electricity. And as I said, the tin has lost an electron, because many metals, they do that, just lose electrons. So if we can give it back, it'll separate out. Right, so let's get going. What are we going to need is we're going to need the little Petri dish that comes with the set. And again, if you don't have the set, don't worry. It's absolutely fine. But I'm going to use that here. Okay. The other thing we're going to do, I'm going to obviously need to put on my gloves and my goggles because we're going to be working with chemicals. Now, for those of you guys who've seen my sessions before, my webinars before, you know that when I put my gloves on, have you ever seen the movies, you know, with the, exactly, I can see Mark the surgeon, there we go. So have you seen the movies where, you know, in the TV shows where the surgeons, they put their gloves on and they're like, I'm ready for surgery or something. They probably say something a lot cooler than what I just said. But anyway, there we go. And I love when they do that. I have no idea why they do it. I just thought I would do it too. So I hope you guys are okay. And I can see someone's put negatrons for electrons. That's true. There we go. Perfect, because they are negative. So remember, electrons are negative. Okay, fantastic. Now, there is a process in chemistry, okay, called reduction. Okay, reduction. Now, when you reduce something, it's reduction. Okay. Now, weirdly in chemistry, and there is a reason for this that you understand later on, but just want to quickly tell you that when something gains electrons, so it seems weird because reducing seems to be taking away, but it's the opposite. I promise there's actually a valid reason for that, but it did confuse me a lot when I was younger. I understand it now. Rather than going into that, I just want you to understand reduction is where something gains electrons. So this tin that's in here currently is missing an electron. That's why it's stuck to this chloride, because remember, opposites attract. But if we could give it back its electron, it's no longer stuck and it can be free. Okay, right. So little poll for you guys. Kat, I wonder if you could pop that up. What is reduction in chemistry? I know I just said it. I'm not condescending you guys. I'm just making sure that you guys are ready there. And I'm going to grab my goggles as well. Safety goggles. Okay. All right. Perfect. So what is reduction in chemistry? Is it taking away electrons? Is it adding electrons? Is it having fewer of something? Or is it getting shorter? Okay. Reduction. It seems like it could be quite a few of those ones, but is it taking away electrons, adding electrons, having fewer of something, or is it getting shorter? Okay, well done. I can see lots of you guys have done the poll, which is fantastic. Sorry for you guys who are not on, not in the thing. As I said, you can sign up. Now, actually, it's interesting. I got 45% of people said taking away electrons, and 45% of people said adding electrons. Okay, reduction seems like it's reducing, but in fact, it's adding electrons. Okay, the reason is it takes away something else. What's actually going to happen is we're going to be taking away the chloride. That's why it's called reduction, but we have to add electrons in order to do that. Yeah, I can see people are paying attention. Well done. gain of electron, loss of oxygen. Well done, guys. You can see it's great. Well done. Okay, fantastic. Good. So reduction is where we're adding electrons, and we're going to do that. Now remember, electricity is moving electrons. So using these batteries, now batteries are effectively like a pump that pumps electrons along. Okay, and that's all electricity is. It's just moving electrons. Okay, so if we can add the electrons to the tin in here, the tin will be free and we'll actually see it forming. Okay, brilliant. Right, so what we then need to do is we're going to need some sodium hydrogen sulfate, okay, and we're going to mix that with the tin chloride. So what we do is to just open this up here. There we go. I'm just going to make sure. Now I've got my goggles and my gloves. I'm being safe. Owlie would be proud. Are you happy with me, Owlie? Fantastic. Now, Owlie hasn't got any goggles, sadly. I'm going to get him some, I promise, so he can come a bit closer in some of the experiments. But today, he hasn't got them. Right. Now, the thing is, when we actually do these sets, this has a little stopper in the top to kind of protect it from leaking. So what you do is with the set, and again, if you haven't got this, don't worry, I'm going to just show you through the whole set anyway. What happens is we use a paper clip that comes with the set, and I'm just going to push that into... Here we go, just push that in, and that actually breaks a seal in there. So now this liquid can come out, the sodium hydrogen sulfate. And what I'm going to do is I'm going to add that to the bottle of the tin chloride. Okay, so we're just mixing the two of these together. What that's going to do is it's going to free the tin ions. So do you remember an atom that's gained or lost electrons? The tin is missing an electron. I'm now freeing it, and if we can add an electron, it's going to be even more free. So here we go. This is really just free the tin today, isn't it? Free tin. Right. Here we go. You can be free, little tin. Here we go. Right. So I'm just going to add that in there. Now, here we go. I'm just squeezing this in. Sorry, it takes a moment. I don't want to do it too fast to... there we go. Okay, right. So now I've emptied this entire bottle of the sodium hydrogen sulfate. Here we go. All right, perfect. And just... close that up even though it is empty. Fantastic. Now what we do is I take the... Okay, here we go. Right, now what I'm going to do is I'm going to take... We have a little red cap here, and I'm going to put that onto this, okay? The reason we use the red cap is so that we don't get stuff getting into the other chemicals, okay? All right, here we go. Now, what we're going to do is I'm going to mix that up, okay? So now what I've got is a mixture of the tin chloride and the sodium hydrogen sulfate. And what that does is it allows the tin molecules to start floating around. But they're called ions, remember, because they haven't got, so they're missing that extra electron around the outside. Now we need to give one back to it, and we will see what happens. Okay, so I think that's a good shape. Now what I'm going to do is I'm going to make sure that you can see my table here. Okay, so what I'll do is I've got this little black card which makes it a little easier to see, but I'll use that in a minute. So what I'm going to do here is I'm going to add the tin chloride and the sodium hydrogen sulfate mixture to this. Here we go. So what's this? I'm just going to add this to the, here we go, to this Petri dish here. Okay. All right, cool. Brilliant. That's excellent. I'm just seal that up to be safe. Okay, fantastic. Right, can you see that? Now, hopefully you guys can see this okay. So I just need to make sure that everyone can kind of see. Can you see that it hasn't sort of spread itself out? Okay, now the reason for that is because of something called surface tension. Okay, now the molecules within this are ionic. Remember, they're attracted to each other, and it effectively creates this sort of attraction, or this almost stickiness on the top surface. Now we get that in water very often, where water will trap bugs and insects get stuck in the top. Okay, so it's, you know, and it's really hard for them to get out. The same thing, it also allows drops to kind of hold together. So at a very small level, water kind of almost becomes quite sticky. That's the same thing that's going on here. Now we have a trick for that to mean it spreads out really nicely, and it won't react with it, but it's liquid soap. Okay, just normal like hand soap or dishwashing liquid or dish soap. Okay, this little soap, what it does is it actually breaks the surface tension, and in fact that's what we use. That's why we use it for cleaning ourselves, essentially. Right. So what I'm going to do is I'm going to take a little drop of this, and I'm going to just show you what happens. It's actually pretty cool, right? So here we go. Now hopefully you guys can all see that. And what I'm going to do here is I'm going to drip, just a drip. Now watch what happens. What I'm going to do, in fact, what I might even do is I might just turn off one of the lights so you can see a little bit clearer with a bit more shadow. Okay, so let's have a look at this. Watch, just one drip of this and watch what happens to it. Here we go, and one drip. Watch, look at this. Can you see that? Hopefully you guys see that. It actually closed up the gap. And in fact, I'm going to add one more drip because we do need two just to make sure that it's completely... Right, good. So now, what I can do now is I can just move this around and it's coated the entire bottom of that. It's spread out nicely. Okay, brilliant. Right, now, here we go. So what we're going to do now with this is I'm actually going to place this onto this little piece of black card because it just makes it a little bit easier to see what's going on, okay, within there. Right, we can see this slightly sort of milky liquid here. There we go. Just sort of spread that out. Fantastic. All right, now, good. Now what I'm going to do is I'm going to add electricity to it. So remember, guys, by adding the electrons, the tin that's lost its electrons is no longer going to become attracted to the other molecules, and it's going to separate out and form beautiful crystals. So what we need to do now is I've got some little wires here, okay, that I can connect to it. Now what's going to happen is I'm going to connect the red wire, okay. The red wire is, here we go, this is the positive end, okay. So just remember the positive is actually going to be taking electrons because it's got positive. Here we go. Now what I'm going to do is I'm going to connect that here, okay. Now by connecting it, what's going on here is I'm actually, you can actually, I've clipped it to the edge. It's actually inside the water there now. So not the water, sorry, inside the mixture. So the liquid. So what will happen now is if I put the power on, it will actually conduct. Okay, we'll actually pass electricity through the liquid. Now what I'm going to do is I'm going to use the black wire and I'm going to connect that. Here we go. So hopefully you guys can see okay on this. Okay, so what I'm going to do is I'm going to connect the black wire here. Okay, just to the black end here. We have to be very, very careful to make sure we've got the same colors. This is the negative end. The black end is the negative end of the battery. Okay, now the negative end, this is the end that's going to have. So let me just really quickly say this. The negative end is the important end because this is the one that has electrons because electrons are negative. Okay, so this is the bit that's going to add it. And this is also the business end. This is the exciting end of the experiment. So what I'm going to do is just connect this now here so you can see. Here we go. I'm just going to connect it there. Now there is electricity passing through this mixture, okay? But let's have a look. Let's have a look what's going on here. Now, almost immediately, I can actually see some little. Now, it's very hard to see from there, but what I'm gonna do is I've got a little microscope here, and what I'm going to do is I'm going to point it at this, and I'm going to see if we can. Actually, now there is something shiny. It's actually growing. What's actually happening here is these little trees here are going to start to grow. Okay, so but let's have a look now. They're actually starting to grow already. But what I'm going to do now is I'm going to, as I say, use my little microscope and try not to let it get in the way of you guys. So just give me a second as I line this up. But as you can see, look at this. Can you see that under the microscope? There's the connector. And look at this. Can you see it almost looks like cracks or shards? There we go. Now they're actually growing these. There we go. There we go. I don't know if you guys can see that okay. There we go. Yeah. So there we go. It's very, very cool. Okay, sorry, I'm not great at using this yet, this microscope, but I'm just trying it out today. So part of me was thinking maybe I shouldn't actually use it, but I'm really glad that I am now. I'm getting better with it. So yes, let's have a look. I'll keep looking at this. Now, can you actually see it growing there? Isn't that incredible? It's absolutely incredible. I love this. I love this experiment. In fact, Owlie loves it too, so I hope you don't mind. Owlie's going to come and join too and have a look. Owlie, if you sit back a little bit, just because you've got, I want to make sure that you, yeah, he loves this experiment, don't you, like Owlie? Yeah, look, you can see they're kind of growing there. Now, of course, what I'm going to do is I'm going to go back to, I'm going to pop you there, Owlie. I'm going to go back to the microscope so you can sort of see what's going on here a little bit better. But you can see they are sort of growing. Let's see, I'm getting a bit better. Sorry, guys, for the slightly shaky images. But look at this. Isn't that incredible? Now what I'll do is I'll see if I can change the focus on this as well. There we go. Look at that. Isn't that amazing? Love this. Okay. There we go. And that's what's being formed at the electrode there. Okay. And look at this. Oh, yeah, I'm not very good at this, am I, yet? So thanks for being patient. You guys are really patient with me. But isn't that amazing? Okay, fantastic. Right, good. So now what we can see is it's actually starting to overtake the entire thing, and they're going to start heading towards the red electrode, okay? So now, right, so just quickly, while we'll leave that to kind of keep going, basically, Owlie's going to come and sit here. Yes, essentially, I know you want to, you keep an eye on it, Owlie. There we go, perfect. Now, essentially what's going on here is, as I said, the tin that's inside this mixture in the tin chloride has lost an electron, and the chlorine has an extra electron, and that's why they're attracted to each other. But by giving this electron, using the electricity, what then happens is the tin is then free to just be how it wants to be, which is why this beautiful, beautiful structure is growing here. And it is shiny and it actually looks like metal. Okay, it's quite hard to sort of see from there. But yeah, there we go. If I just keep going, yes, you can sort of see the shiny thing there. Okay, perfect. Now, yeah, so as I said, what's happening, this is growing here, and I'll make sure we've got that there. This is growing slowly. Now, what's actually happening at the other electrodes? So those of you guys doing it at home, have a look at the other electrode. Have a look at the red electrode, the positive one, okay? Now, what we can actually see is we can actually see that the red one is actually starting to disintegrate. It's actually starting to actually go dark, and it's actually being eaten away. Now, what's going on there? Okay, so let me just tell you, these wires here, okay, the actual crocodile clips at the end are made of steel, which is mostly iron, okay? Now, the iron, do you remember that at one end it's giving electrons, at the other it's actually going to be stealing electrons because it's positive. It's positively charged, and it actually steals electrons. So the black end is giving electrons, and the red end is actually taking electrons. Now I can see some people who, yeah, it's going black. Now I tell you, I wonder if I can move my thing around so I can actually show you this, because it would be good to sort of show you. I think it's going to be, yeah, as I say, it just takes a bit of time for me to get used to. There we go. Oh, there's the red one. So I follow it up. Can you see that it's going black there? Look at that. And it's actually going black. Now the reason, as I said, the reason it's going black is because the iron that's actually in this metal is actually taking electrons. Okay, it's actually taking electrons out of, and then what happens is those actual atoms of iron are then being released into the mixture. So in fact, right now into the mixture, lots of iron is being released as well, and it's coming from the electrode. So eventually that's going to completely dissolve and disappear. So the red end is going to just stop working. But it's okay, I've got other crocodile clips, and I just wanted to make sure I'd sort of shown it to you. Let me see if I can just do one more from above, just so we can kind of just see. You can kind of, there's a bit of a reflection, sorry about that, but so can you see all of those there? So I wonder, do I need to get closer or further away? There we go. Now you can actually see the shards. I'm sorry it's a bit shaky, guys. Look at that. Isn't that amazing? It's kind of almost like little icicles there. Okay. All right, perfect. So the main lesson for today, the main kind of concept that I wanted to guys to show you is that electricity isn't just used for things like lights and stuff like that. We actually use it in chemistry, okay, to do amazing things and split apart molecules. Now, obviously, there's lots online, and the MEL kit actually has all the details and things of what's basically happening here with the explanation and things like that. So have a look at that as well if you want to know more detail. But I think that the big thing that I wanted to sort of show you today is how electricity can be used to split apart molecules that are already in solutions and things like that, which is actually incredible. I'm actually going to make sure I disconnect this. Remember, to be safe, we'll just disconnect the electricity. Don't let it keep running, but I will let you see what it looks like. There we go. you can see that it's sort of formed this beautiful, beautiful structure, and that actually keeps growing the thing. So, as I said, electricity can be used to split apart these ionic substances, which is really, really cool. And it can be used for so many more things, but it's just one of the tools that chemists have at their disposal. Now, we've picked an experiment here that just looks really cool, which is great, but it can be used for many, many more cool experiments. And so I hope what we'll do is we'll show more of those as we go forward in the future. And I wanted to delve a little bit more into the science. So I hope you don't mind us looking at the atoms, looking at how atoms were made. Please, as I said, go on the MEL Science, the MEL Chemistry apps. They are fantastic because there's lots of lessons on how these ions are formed, how salts are formed. You can even go and delve and be inside and the molecules of water within ice. It's some really, really fun stuff. So I still haven't got to the end. I've been exploring it and finding it really, really fun. Okay, fantastic. All right, well, look, I just wanted to say you guys could have been doing lots of other things today, okay? I imagine there's lots of other things you can do, okay? So I just want to acknowledge you for being here with us. We love having you here. As I said, sometimes learning for me at school wasn't always the most fun, but I have to tell you now I love learning. I'm constantly learning and really, really enjoying it. And Owlie and I, we love learning. So, and it's also been fantastic having all your questions and things like that stuff. I can see tons and tons of questions in the Zoom chat. Usually after the session, I have a little read through all of them and things because I might have missed some. But yeah, Owlie, yeah, you happy? Oh yeah, Owlie said to remind you to take photographs if you've done this and take videos and things like that and post it on social media. If not social media, email them to us just at the email address below, which is melacademy@melscience.com. If you guys are on Facebook or YouTube or anything, please join, go to melscience.com/academy. All you have to do is just sign up, and there's no spam or anything for you guys, but it's free, and you basically get to come and join the Zoom chat, which means you get to be part of the discussion and get to do all the kind of the polls and that kind of thing, basically. All right, well, thank you so much for joining us. Just acknowledge you for being there. Thank you very much for coming to our home here in London and learning some science and things. I'm glad. Thank you very much for being patient with me on this, on my new use of of my little USB microscope. Still haven't quite got it right, but I thought maybe you wouldn't use it, but I'm really glad I did today. I hope you guys were able to really see nice and close up with that. So yeah, perfect. All right, now, fantastic. We're around all week. These Wednesday sessions will be sort of based a bit more in detail, but the rest of the sessions will have lots of DIY experiments. Please come back, invite your friends, and fantastic. And have a lovely rest of your Wednesday. Take care. All right. Bye-bye, guys. Oh, wait, shall I show you one last time? Here we go, just on the table, just to see where... Yeah, it's still looking pretty cool. Okay, so, all right, guys, see you again soon, and take care.